Good morning everyone. In the last lecture we discussed about the reflection of waves, longitudinal as well as the transverse wave from the rarer medium and the denser medium. Today we are going to discuss a very important topic in this chapter. It is the superposition of wave, which is the name of this chapter. What is the superposition of waves mean? We first of all see the definition and the meaning of superposition of the waves. Okay, so what is the superposition? When two waves, when two waves arrive at a point simultaneously, when two waves arrive at a point of a medium simultaneously, then each wave produce its own displacement. Each wave produce its own displacement independent of the other wave. Okay, and the total displacement at that point is equal to the vector sum of the displacement produces by the individual wave. This is called as the principle of superposition of wave. So, what is the meaning of superposition of wave? Consider a single point of a medium at which two waves like this, these two waves arrive simultaneously at the same time. They hit this point of the medium. Then what happens? Then each wave produces its own displacement. For example, this is the wave first and this is the second wave. Then what happens? This first wave produces its own displacement at the particle. This particle displaces with some amplitude depend upon the energy of this wave. Okay, now at the same time the second wave also displaces this point with the energy having given to the wave second. So each wave produces its own displacement independent of other, and the total displacement of this point, the total displacement of this point is the vector sum produces, the vector sum of the displacement produces by each wave. For example, when this first wave collide or this first wave reach this point displaces with the amplitude a1. Similarly, when the second wave arrive at this point, then it produces a displacement a2. Then we can say that this point is vibrate with the displacement is equal to the vector sum of these two. So we can say that if so it may be a1 plus a2, or it may be a1 minus a2 also. Okay, so what is depend upon this positive and negative sign? This positive and negative sign indicate that if these two waves are in phase, if these two waves are in phase means same, the trough of first wave and the trough of second wave arrive at a point simultaneously, or crest arrive at a point simultaneously, then they are in the phase. And when they are in the phase, the amplitude becomes a1 plus a2, maximum amplitude. This particle vibrates with the maximum amplitude, or it has a maximum displacement. And when this minus sign arrives, this minus sign arrives when crest of one wave and the trough of second wave arrive at this point. Then we use here the minus sign. So what is the meaning of vector sum? Vector sum means we use the positive sign when the waves are in phase, and we use the minus sign when the waves are out of phase. Out of phase means crest of one and trough of the second arrive at a point simultaneously, then the displacement will be decreases. Okay, is the vector sum a1 minus a2. So this is the superposition of wave. We again define this superposition of wave like this. Consider two waves arrive at a point of medium simultaneously, then each wave produces its own displacement independent of the other wave, and the resultant displacement at the point is vector sum of the displacement produced by each wave. This is called as a superposition of wave. Now we are going to see the analytical treatment of the superposition of wave. Means when two waves arrive at a point simultaneously, then what is the resultant amplitude of the particle? We are going to see it analytically. Okay, so first of all we need to know the superposition of wave, and now we are going to treat it is analytically. Okay, so as we know, this motion of a particle about the mean position. Okay, suppose this is the point when there is no sound, there is no energy is traveling, but if we are speaking or some light is passing through the medium, these particles are vibrate about their mean position, and such type of motion is nothing but the simple harmonic motion. So to see the superposition, to study the superposition of the wave analytically, we need to use the concepts of the simple harmonic motion. So what is the simple harmonic motion? The motion in which the force is directly proportional to the displacement and always directed towards the mean position. So we are going to start here the analytical treatment of the superposition of waves. Means when two waves arrive at a point simultaneously, then what is the resultant amplitude at this point? Okay, so consider two waves as we discuss state in the definition that when two waves arrive at a point simultaneously, means we are going to consider here two waves. Consider this wave represented as y1 is equal to a1 sin omega t, and the second wave as y2 a2 sin omega t plus phi. Now what are the difference between these two waves? Okay, this wave represent the particle or the wave. This is the wave. This wave represent the mean position, and this second wave, this second equation represented that the phase difference between two is equal to pi. Means one wave is starting from the mean position and the second wave is starting from a position after a phase difference of pi. Because here a1 sin omega t and here is the a2 sin omega t, means this portion is same. What is the difference between them? The difference is nothing but the pi. This difference is called as the phase difference. Means if this wave is starting from the mean position, this wave is starting from the position with a difference of pi. Here the amplitude of the wave starting from the mean position is equal to a1 and that of the second wave is equal to a2. So we are going to discuss the analytical treatment of these two waves. So what is the resultant displacement? When these two waves arrive at a point simultaneously, then what is the displacement, resultant displacement of the point? The resultant displacement we write here y is equal to y1 plus y2. Okay, So what is y1 is equal to? This y1 is equal to a1 sin omega t plus a2 sin omega t plus phi. Okay, now we can expand this term sin a plus b. So what is the formula for sin a plus b? Look at here. It is equal to sin a into cos b plus cos a into sin b. So by using this formula, this expansion, we can write here it is a1 sin omega t plus a2 sin omega t into cos phi plus cos omega t into sin phi. Now we multiply this term with a2, so we get here a1 sin omega t plus a2 sin omega t into cos phi plus a2 into cos omega t into sin phi. Okay, this is the equation. Now what is the common in this? Here sin omega t and here is also sin omega t. So we take common from this term a1 plus a2 cos phi and this sin omega t is the common plus what remain? It remains a2 cos omega t and that of sin phi. Okay, so we can also write this like this. It is sin phi cos omega t. Okay, we can interchange the position also. So look at here, this is the function of cos and this is the function of sin. So we are going to substitute these two terms. It is a1 plus a2 cos phi is equal to a cos phi and this a2 sin phi is equal to a sin. Okay, so we substitute this equation in this. So what is the y? This y is equal to a cos phi into sin omega t plus a sin phi into cos omega t. So if we take common a, we write like this sin omega t into cos phi plus cos omega t into sin phi. Now what is this? This is the expanded form of sin omega t plus phi. So we can write here a sin omega t plus phi. Okay, so here also phi, so we can denote this phi with the another angle. So as given in your book, we use theta here. So right here is theta. All the procedure are same. We are considering here is a theta. This is theta. This is also theta. This is theta. Okay. So this is y is equal to a sin omega t plus theta. So what is this equation? What this equation represent? This equation represent that the resultant wave is also a simple harmonic progressive wave which contain amplitude A, resultant amplitude A, and resultant phase difference equal to theta. Okay. So in this way we discuss about the resultant or the superposition of waves. Now we are going to derive a relation for the resultant amplitude. And what is the resultant amplitude? We are only writing the final equation of the resultant amplitude for A. So what is the amplitude of this superposition after the superposition of waves? So what is the procedure? The procedure is like this. To determine this A, we squaring and adding. So A square sin square phi or theta plus A square cos square theta. Okay, and then what is this? This is equal to A2 sin phi square and plus A1 plus A2 cos phi x square. After the simplification, what is the simplification of this? Sin square theta plus cos square theta is equal to 1. So this is A square, and what is A? This A comes out to be, it is this A as given in your book. It is equal to A1 square plus A2 square plus twice A1 A2 cos. This is the equation for the resultant amplitude. So if we know the values of A1, A2 and difference between the two waves starting, so we can easily calculate or determine the resultant amplitude by using this formula. Okay, now there are some special cases which we are going to see here. What are the special cases? The special cases are like this. If the phase difference, that is the value of phi, changes, if the angle between the two waves changes. So we are going to see some special cases here. So the first case is if this phi is equal to 0. Consider at the initial state of this equation, we say that phi is nothing but the phase difference between the two waves which are going to arrive at a point simultaneously. So if the phi is equal to 0, what it means? It means that the two waves are starting from the mean or the starting from the same point. Okay, not from the mean position. They are starting from the same position. If phi equal to 0, it means the two waves are starting from the same position. Either it is mean position or it is an extreme position. So if phi is equal to 0, if they are starting from the same position, the phase difference between them is equal to 0. And what happens? The resultant amplitude is equal to phi equal to 0 means cos 0 is equal to 1, and it is 1 multiplied by twice a1 plus a2. So we can write here this a1 square plus a2 square plus twice a1 a2 Okay, and this is nothing but the square of a1 plus a2 and its square. The square root and square root cancel, so we can write the resultant amplitude A is equal to a1 plus a2. So what is the special case? The special case state that when the two waves are starting from the same position, then the resultant amplitude A is equal to a1 plus a2. These are also called as in same phase. They are in the same phase, right? So this is A is equal to a1 plus a2. We can keep another condition here, such that if a1 is equal to a2, if a1 is equal to a2, then what is the resultant amplitude here? The resultant amplitude is equal to twice of A. It is twice the initial amplitude. So this is the relation when the phi is equal to 0, that is the wave starting from the same position or they are in the same phase. Okay, same phase means crest of one coincide with the crest of the other, or trough of one coincide with the trough of the other wave. So when this such case arises, the resultant amplitude is equal to a1 plus a2, or if a1 is equal to a2, then this resultant amplitude is equal to twice of a. Now we are going to see the second case. So what is the second case? The second case state that if this phi is equal to 180 degree or pi radian. Okay, if the difference between the two waves is equal to pi radian, or it is equal to 180 degree, then this equation becomes, for the resultant amplitude, A is equal to under root a1 square plus a2 square minus twice a1 a2, because cos of 180 or cos of pi is equal to minus of 1. So we are given the sign of minus here. This is nothing but the square of a1 minus a2. This square root and square get cancelled. Therefore, this becomes a1 minus a2. So when the phase difference between the two waves are 180 degree, that they are starting from the opposite points, they are out of phase. Then this resultant amplitude A is equal to A1 minus A2. A1 minus A2. If this A1 is equal to A2, then what happens? Then the resultant amplitude A is equal to 0. So when two waves are in out of phase arrive at a point simultaneously, the resultant amplitude at that point is equal to 0. And if they are in phase, they are in the same phase, so we can say that the amplitude increases. So the cancellation or the enhancement of the amplitude when the two waves arrive at a point simultaneously, it is called as a superposition of waves. Okay, now we also consider that the relation between the intensity and the amplitude. Okay, so what is the intensity? If the two light waves are arrive at a point simultaneously, then we can measure the intensity of the resultant wave. So how we can write? The intensity I is directly proportional to the square of the amplitude. Intensity is directly proportional to the square of the resultant amplitude. So if we need the maximum intensity, then this is proportional to. What is the maximum intensity? This maximum intensity is directly proportional to the sum of these two. So we can write here it is equal to A1 plus A2 whole square. This is the maximum amplitude we are getting. If we need the minimum amplitude, minimum intensity, so what is the minimum intensity? The minimum intensity is directly proportional to the amplitude. So when the amplitude is minimum, it is equal to A1 minus A2 and its square. So what is the ratio of I maximum to I minimum? It is equal to A1 plus A2 square divided by A1 minus A2 square. So in this way, this intensity of the resultant wave is depend upon the square of the resultant amplitude. So in this way, today we discuss the superposition of wave. We define the superposition of wave. We explain what is superposition of wave. Then we derive a relation for the resultant displacement and amplitude. Then we are moved towards the special cases, and in the last we see about the intensity, the relation between the intensity and the amplitude of the wave. So in this way, in today's lecture we discuss all about the superposition of wave. In the next lecture we are going to discuss the types of wave, and the first type of wave due to the superposition is called as the stationary wave. We discuss about the stationary wave in the next lecture. So this is for today. Have a good day. Bye.